What's up guys, this is Balázs from RacingBrick. LEGO recently announced that their first standalone 3D printed element, this tiny adorable duck, is available for purchase in the LEGO house during weekends in November and early December. It is a super limited offer, you can only get it in Billund, you need to sign up for it, so if you manage to grab one, consider yourself super lucky. Standard LEGO is made of injection molded plastic, you can actually see how it is made if you visit the LEGO house in Billund. If we take a closer look at that tiny little duck, it has a somewhat rough surface but seems to be amazingly detailed for the size. 3D printers are widely available nowadays. Does it mean we could make something similar at home? Actually, could we easily 3D print LEGO pieces at home? Well, I got some bad news. This duck was made with a technology called powder bed fusion, most probably SLS, which is short for selective laser sintering. It's a technology where high-powered lasers are used to bind thin layers of plastic powder together into a solid structure. These printers are mostly used by professionals and they cost tens of thousands of dollars or even more. Apparently we won't be making these type of 3D prints at home anytime soon, but what can be actually done then with the technology that is widely available and affordable? Most consumer 3D printers use another printing technique called FDM, short for fused deposition modeling. It works by extruding different plastic materials through a heated nozzle, melting the material and building objects layer by layer. I have an older FDM 3D printer from 2016 made by Prusa Research. I bought it as a kit, spent a few days with the assembly itself, did use it for some home DIY projects, but not really for LEGO. But now we have a chance to take a look at the possibilities with a more recent 3D printer, because the great folks at Flashforge reached out to me and asked if I wanted to test one of their most popular models, the Adventurer 4. So, this massive box showed up in the studio, let's unpack it quickly. Okay, it wasn't that quick, the printer is actually huge and very heavy. This is a mid-range model that you can buy around 900 euros or dollars, depending on the configuration and your location. It has a print volume of 22 by 20 by 25 centimeters, has a magnetic flexible upper plate that is easy to remove, heated build bed, removable nozzle, built-in camera, Wi-Fi, and so on. If you are interested in the specs and details, I suggest to take a look at the official product page, the link is in the description. As I mentioned, I have some experience with 3D printing, but not that much. I hear more and more often people asking if 3D printing LEGO compatible parts is possible, especially when they realize that older rare pieces that are not in production for decades can easily cost a small fortune on Bricklink. I would like to test today how a 3D printer like this can be used for anything related to LEGO if you are not a black belt 3D printing professional. This video is actually the first in a series. I am planning to explore the possibilities of LEGO related 3D printing in multiple videos. I had to find a sturdy base for the machine and I don't want it to occupy my photo table for weeks, so that will be your spot. Sorry Ferrari, you need to wait a bit before you can join your friends on the wall. Here are the accessories, a power cord, some cables and tools, 1 kg of PLA filament and a quick start guide. Now let's fire it up. Okay, I hope this can be switched off. It has a nice color touchscreen, I'll do the initial calibration and configuration. The material I have here is PLA, this is the most widely used plastic filament material. The printer could handle ABS, PETG and a whole bunch of other weird letter combinations, but this one is probably the easiest to manage, so we will start with that. Let's install the filament. Oh, meanwhile it found a new firmware. Now I need to load the filament, then wait for it to appear at the nozzle. Success! To be able to 3D print anything, you need an application called a slicer. This is basically a tool that translates 3D objects to code that the printer understands, plus all the required parameters for the process. I will use the FlashPrint app by Flashforge, printer is connected to the Wi-Fi, let's load the test cube. Now I need to slice it, which basically breaks down the object for the printer. I can preview to see how it will look like and then send it to the printer. Having a Wi-Fi connection is super convenient, otherwise I would need to copy the file to an SD card or USB drive and load it from there on the printer. This way I will be able to hide the printer even in the garage. This one was not in the quick view guide, but here in the app you can connect to the camera and see what's going on. Well, the theory is good, but honestly I don't see that many details. Probably I could see if something was totally messed up. So here is our first result. The printer created a sort of sandwich below the actual model, this is called the raft. My old printer did not do this by default, so that was a surprise, but as I see, the box itself turned out to be pretty good. Now let's see what else do we have here. Here's another sample, slightly bigger. It's also a longer build, will take about an hour. This is a flexible snake. You can see that PLA is a quite flexible material compared to ABS, for example. Okay, let's print something else now, a bit more useful maybe. One of the key requirements of home 3D printing is to have an actual 3D model in a proper format. You can of course design stuff yourself, but that's for another day. Luckily there are great sites with 3D models to print, one of them is Thingiverse. I chose this SD card holder as it looks something useful, but I don't want it in bright red, so I will switch to black PLA for now. Let's remove the raft. As you see, the bottom didn't turn out to be very nice this time. This model is somewhat special as it has a hinged cover, but the two sections are printed together, no assembly is required. I can put an SD card here, a microSD here, nice. The microSD card fits well, the bigger one is a bit loose. Not sure if it is supposed to close firmly, but that doesn't work either. And this shows one of the main challenges of 3D printing at home. I don't know at this point if this is a problem with the file, or maybe my settings, or maybe the material I used. There are many different factors influencing the end result, so if I wanted to make this work perfectly, then I had to start tweaking it, edit the file or my printer settings, printing maybe 3, 4, 5 iterations. Here are two other functional prints. Here's a cat phone stand, because of course we need one. I really like the surface here, super smooth, very nice satin look. The top is also okay, but the bottom where I removed the raft looks a bit rough with all these remaining strings. Here's another useful print, a lens cap. I could buy these for €2, but I can also print one in an hour or so, and it works pretty well. The bottom is quite smooth this time, despite the raft being used again. So, we've tried a couple of household things so far. I know you want to see Lego prints finally. There are many results for Lego on Thingiverse, but I wanted first something simple that I can test with both system and Technic pieces, so let's try to print this classic Technic 1x4 brick. This is my first attempt. As you see, this side was down, so it looks quite ugly with the remaining pieces of the raft. It is not flat either on this side. Now let's see how it works with the Lego pieces. Bottom connection, failed, doesn't fit. Top connection, doesn't fit, failed. Pin connection, very tight, failed again. Okay, so the first attempt seemed to be a complete failure. I will try to switch back to the original red PLA that came with the printer, as that one has predefined settings in the slicer. I will also try to print without draft this time, although this wasn't a success previously. As you see, something very weird is going on there. It really shouldn't look like this. I have no idea what's wrong. If any of you have any ideas, please let me know in the comments. Okay, let's get back to the raft. I tried to look up something useful online. People of Reddit said I should increase the space between the model and the raft. This is this value. Let's double it according to the instructions. Another change, I will rotate the model to have smoother sides. We'll see what happens this way. Okay, so this element was way easier to separate from the raft. The updated settings apparently worked. How about the compatibility? Bottom is a no-go. Top is too loose. Pinholes are somewhat better, but still too tight. Now let's increase the resolution by dialing down the layer height. This will make the printing process much slower, but hopefully we'll have a finer piece at the end. So, how is the result now? It's getting better. One side actually connects on the bottom now, although the other one doesn't really work, and the top connection is still very loose. The pinholes are much better on the other hand, a bit tight, but I've seen worse pieces at compatible brands already. Apparently, stud connections require higher precision. What about something for Technic? Here are two pieces that don't exist in Lego form, this small 2x2 L piece and the bigger 3x3 one. This one was printed flat, so as you see the bottom section is quite messy, but the pinholes work remarkably well. This bigger one was printed in this position, and again the pinholes are pretty good, and from a functionality standpoint this part could work well with other Lego Technic pieces. They wouldn't win any beauty contest for sure, but if you need the functionality and not the look, then they would be okay, I think. So for the end, what else could we print that is actually useful for Lego? I searched for something on Thingiverse and found this cool looking stand for the Speed Champion Saudi set. Some smaller details could look better, but the car fits and I think it looks awesome on it. Now let's sum up our experience so far before this video gets super long. Setting up this Flashforge 3D printer was way easier than the one I had previously. No assembly required, the closed structure is a big plus, the Wi-Fi connection and the color touchscreen are all features that are very nice to have. I managed to print a few things without tinkering with any parameters, and the end results were pretty good in general. Objects that require precision, such as the SD card holder or the lens cap, seem to be a bit hit and miss though. You are either lucky with the default parameters and the model as is, or you aren't. The model itself is critical. It's better to check what experience others have with it. 3D printing as a hobby apparently requires way more than just the purchase of the printer. It is still not a plug-and-play experience like using an office printer. You need to invest time, but we can get nice results fairly quickly, and the Adventurer 4 seems to be a decent choice for this purpose. Printing LEGO-compatible elements, on the other hand, seems to be a whole different world. LEGO requires very high precision. The machines that manufacture LEGO bricks have tolerances as small as 10 micrometers. This is something that we cannot achieve with these printers at this point, so to answer my initial question, no, I don't think we can print easily pieces at home that can replace LEGO bricks. I have to emphasize the easily part. As you could see, printing studded elements could be the most challenging. Printing Technic compatible parts might be more successful. In my next videos, I will explore what other compatible or replacement elements can be printed that don't exist in the LEGO world, and I will also try to explore the settings and see how they can be tweaked to have better end results. We will also compare some professionally printed elements with their home printed equivalents, so there's still a lot to do. If you have any ideas what to print for LEGO, please let me know in the comments. If you have experience and best practices, then please also share them. If you like this video, then please give it a thumbs up. I also suggest to subscribe with notifications as more exciting LEGO videos are coming soon. See you next time, bye bye.